this video is we move to the last subchapter for the programming challenges on this four topic within the chapter 7, solving calculus problems. So the first one is to verify the continuity of the function. So that should link to our the 7.1 and 7.2 when we're talking about the function, and we are talking about the assumption. That's number 3. We're talking about the limit. So what's the continuity of a function is I can use this chart to give you some visualized understanding. Then we come to look at our challenge, because our challenge is to write a program to verify this concept. So the continuity means is if you have a curve or you have a function called fx, the limit x approaching to a from the negative parts, the direction, then that will be the this and the limit result. And this is approaching from this positive, and this is this fa itself. So if in the condition these 3 together will make the function fx continuously at xa, so which means is if these 3 calculation are in the equally result or equal value, then we will call this function or this curve is continuous at this point. So that is the idea. So from the our this mind map, I also give you a reference link if you want to relearn this concept. So this coming from our online. I hope it's keep available on this page. So they will tell you these 3 different functions or the pictures. Like we see here is the fa, here is the limit, the exist. So here is the limit is equal to fa. So that is the checking point is to see whether our function is continuously at this point. So from the mathematical way is easier. Is we just put this limit approaching to a plus, limit x approaching to a, this negative, equal to fa. So if we fulfill this the condition, then we can confirm this function has the continuity at this point a. So the challenge is to write this program with 2 achievements. One is to accept a single, remember here just a single variable, a function, and the value of that variable as inputs. So definitely we will use our learned knowledge to make the validation to ensure we accept or valid the function. Then second is we write our function to check whether the inputs function is continuous at this point. So and here is the sample test which we will use as the test case. So let's starting to do coding. So quit from our previous, then we will do here. Let's close some now used terminal. So we let me close the earlier. So we are now in the 7.9. So let's all make a new part. 0.709.1. What we call this verify continuity. So purpose is verify this continuity of the function at a given point. So let's think about this. What we need is we definitely need this from SymPy. We need symbol. We need this simplify, and we need this simplify arrow. And what we need is here we have the limit, so we also need the limit. We don't need this capital S because we are make limit approaching to this given the value. So I think it's that the class is enough. So let's start to do our primary code. I hope you are now quite familiar with such kind of the mean code. So this way, let's use our the learning before is we need to accept our function. So from input, enter our function. Enter a function with single variable. And when we have this function, let's do our try. So try f equal to simplify f. So except simplify arrow. Then if that is, we will print invalid function entered. Then else we will do something. So we leave that is then we need to receive some the variables. So variable and this variable we need to put that as a symbol. So but if this f is not valid, we will not do that. So make that symbol is putting here. So variable is a symbol variable. And then we will ask the user to give a. So a is our floating number, I think. Input, enter the point to check the continuity net. Then we have enough. Then we will have to check that is we will get this check. Just to give any name, is a check continuity is our function. So we will transfer what? We transfer first is our function, then this variable, then this given the point. So let's do this definition of check continuity. Then we start this, we can have the first is this f value at this point. It's just f. Use these subs and use a dictionary to put this var equal to a. So, oh, sorry, it's like this. Sub f subs. So we can make it print f sub f value. It's doing the analyze. Okay, it's past the analyze. So let's just make our testing first. So if I give like this, so just one third, 1 divided by x, and our variable is x, and our the a is 1, then this value should be 1.0. Let's put that another. If I put this a is 5, and I should get 0.2. So that means this f value is correct. So let's do the continue. We make this 2 limit. So limit 1 is equal to, use this capital L. We should transfer f, transfer from variable, and transfer a, and the a is the point. It's not an infinitive number, and we should transfer the direction. So direction now is first is the positive. So we put this positive, and we directly make that calculate. So that is the 1 limit. And another side, the limit, we call that is the limit 2. The only difference is this negative direction. So then we have this number, 3 numbers. The easier way is if we can calculate if f value is equal to L1 and L1 equal to L2. So then with this and, we are checking is whether these 3 values are same among the same number. If that is, we will print. I think as we finish our evaluation. So this variable, the result is continuity at point. So we will put this format. The 0 is the function, and this b, the 1 is the our defined point, and else we will put this still this one, but different message. So it's not continuity as this. So we can put this not is highlight. So we don't need to return anything. We just call that, and actually D is may not be needed, I think. So let's start to do the verify. Is our function first is this one, and x. So this 1 divided x at 1 should be the continuity. So if f equal to lim off, so I use this shorter, so limit 1, limit. Okay, let's do. So 1 divided by x, x1. So it's continuous at 1.0, and we know it's 1 divided by 0 is not defined. So if we use that, it's quite direct. We should get the negative value or false value. So good is not. So that is the way is you can use this as your own library or tools to check whether a point in any point is continuously. So let's make that to some the complex. So if I put this 2 plus or maybe minus 3 times x plus 6. So this is my variable, the function, and x definitely. I just wanted to see is if at 4 is this continuous? It's continuous because this is just a continuous this line. So that is the way. So you can use this for any valid expression or valid function that you can allow user to input. So I hope it's this to give you some review on the first 3 chapters. I think it's primarily is linking to this limit. So let's link this to here. Then we have this connection, and the next one is we already mentioned is just the inverse the function to this gradient Sn. the method. So let's do that in the next video. So see you. Bye for now.